Hello, my name is Janet McIlvaine. I work at the FSEC Energy Research Center, which is part of the University of Central Florida. And today I'm going to talk with you about the Zero Energy Ready Home certification program and hopefully give you some historical background that you might not be aware of the underpinnings of that program and predecessors. Well, many of the things that we hear about in the news today in the media, concerns about extreme heat and global warming and also affordability of housing are echoes of what happened to our sort of national awareness in the 1970s during the energy crisis that brought everyone's attention quickly to how much energy they were using in their cars. And that naturally turned to, well, what could we be doing at home? And so we saw a kind of birth of a movement towards passive solar design, and in doing so, harnessing the sun in different ways, water heating and PV. And these are pretty typical of what we think of when we think of 1970s passive solar homes. The thing I want to draw your attention to is how large the PV arrays are on these modest size homes. It's particularly apparent in this one in the bottom row where you have this enormous PV array. It is providing some nice shading, but relatively modest, even small house, as well as some of the others where you see this large array for a very modest looking size home. So what's going on there is that at that time they didn't have a lot of options for energy conservation or improving energy efficiency that we have today. So they had pretty inefficient homes, and that necessitated very large, expensive solar arrays. So that didn't really get off the ground too much. It still continued into the 80s and even into the 90s and today. But let's fast forward 30 years into the late 90s. Now, by the end of the 90s, we had learned just a whole bunch about how houses use energy and what makes them safe and healthy and durable. And some folks that work with me decided that they'd like to consolidate all of these lessons into one house, because a lot of the knowledge that we had was kind of onesie twosie, like it looked at a specific improvement or a specific change. And to bring them all together, the idea was, well, maybe we can eliminate all of the load, or at least enough of the load that we can meet the need with solar. So we partnered with a production builder in Lakeland, Florida, where the municipal utility was very interested there in the potential of this idea for peak demand reduction. So what we found was that based on the efficiency improvements, which you can see some of them here in the picture, the white roof, and there's a solar water heater, and there's shading, deeper shadows on the walls, also things inside an interior duct system, high performance windows. All of those things combined reduced the energy consumption of our test house by 70% compared to the control house, which was basically a code minimum house. With the addition of the solar PV production, we almost met the rest of the load. We got down to having only 8% load. So fast forward another 20 years, and here we are in 2022, looking not at a test house production home, but looking at whole communities of zero energy and zero energy ready homes, and homes that consider the cost effectiveness, which our test house did not. But all of these homes that I'm showing here are a part of the DOE website in an area called the Tour of Zero. And they're not only certified under the program, but they are also Housing Innovation Award winners. This could be useful for you to take a look at if you're considering certifying a house under this program. You can find one in your area. You can sort the case studies by location, by climate zone, and to take a look at some of them in your area to see what kind of specifications are needed to reach this high standard, and what would possibly be needed in your homes in comparison to reach that kind of goal. But 5 decades in the making of getting from this conceptual idea that we can power a home, a very customized, specially designed home, to the idea that we can power any home at the zero energy level. So the aspects of our markets that have shifted and changed that make it possible to do this, I've divided these up into 4 types of market interactions. The first one being codes. The advancing energy code over the years pushed our minimum efficiencies higher and higher. And then another aspect are standards, and we have both appliance standards, which set minimums for manufacturing, as well as we have product performance standards, such as the Energy Star Windows standard that allow us to compare products within the same category and make a judgment about which ones are climate appropriate. We didn't have this, even in the 90s. We were just getting started with this, but we'll talk about that in a second. The other market activity is the voluntary whole house certification programs, like the one we're talking about here, and predecessors, Energy Star, of course, being the flagship program that we are all familiar with. And then I've got a 4th category here that I'm calling design, because it relates to things that aren't addressed in the other 3 types of market actors. So among all of these forces of advancement, this program is combining all of that into 7 mandatory requirements for certification. And we're going to talk about each one of those and how it relates to these codes and standards and so forth. But I'd like to throw in this idea that with all of this science churning and working together, what we cannot create through science is a level of sort of public will, and not just the public, but the parts of the home building industry that are needed to work together. And to foster that kind of interest is really important, because without it, none of the other stuff matters. Because all we are driving for here is change in the real world. And without that spark of curiosity, we're not going there. So we have to have a little bit of magic in with all this science if we really want to go places. So these are the 7 mandatory requirements, and I've used this color coding system to highlight that there's one item in yellow that relates to a code. There are several in green that relate to existing standards. And then within this certification program, there are other certification programs noted in blue that are being rolled into this as kind of a consolidator of basically everything we know about how to make the best house we can. And then here's this 4th factor that I'm calling design, and this relates to things that don't fit into the other categories for reasons that we'll go into in a minute. We're just going to jump right in and dive into each one of these and have a little overview of it and some historical perspective on how it developed. So the first one is the baseline of being certified under Energy Star. This is the real do not pass go. If you are not already settled into and consistently building Energy Star homes, I would advise you to pursue that. So again, here's this idea of the science and the magic. Like everything we poured into calculating the HERS index and all of our checklists and everything, that's the science. And it's kind of interesting that it can all be boiled down to basically the size of an index card. But anyway, but the magic here, you can see that even though we know this is a setup shot, I have met people that really feel this way about their Energy Star homes. And that kind of fuels the fire, I think, for a lot of builders. So just a little bit of a history lesson about how that Energy Star program developed over time and the relationship of that as a standard to the research world. We note here, this is a graph that I took from Sam Rashkin's a paper that he wrote, and I've added all of these little time frames here. That as we go from back in the 90s forward, we see each successive iteration of the Energy Star program. And what is behind that I want to just draw your attention to is that while the Energy Star version 1 program was in effect and was gaining market ground, the research world was already looking at how to achieve the next level of efficiency and getting the field work done to make sure that it could be done safely and in a way that was not a detriment to durability. And then those research findings above here get rolled into the next level of the certification program. So this research is kind of a proving ground for what is reasonable in the marketplace. Same thing happened with Builder's Challenge, which fed into the Energy Star version 3 and the checklists. And as the Energy Star, as the Zero Energy Home program takes off and informs the next level of efficiency, we're already thinking about, okay, we can make a house that can run itself, but can we make a house that can run itself and your car? So it's not, we're not at the end yet. We're moving forward. So requirement number 2, I'm going to skim over these that I'm sure that most of you are familiar with, is meeting the Energy Star window criteria, but the background of that is interesting as well. Back in the 70s and 80s, there was no labeling on windows. You could, if you worked very hard, get some information about reflectivity, but there was really no labeling to speak of. And in the 90s, the window industry pulled together and decided to make some standard testing procedures and to label their products so that they could be compared. And that was really the underpinning for the Energy Star window criteria, and kind of opened up the doors for other types of Energy Star products. The other requirements in the second area is the envelope. They've given you right in the standard, the table, and they have made some exceptions and exemptions and contingencies that are described in the footnotes. But one of the nice things about this standard or this program is that they've pulled it all together for you. You don't even have to go out and chase down these tables, which is really nice. Just a bit of historical perspective on the advancing energy codes. So back up here, we see this is the 2015 IECC installation table. So where we are here in the middle of this is much more stringent than where we started out. This is way back in the 70s. There's a model energy code was developed, and it was a national and really was just a model. And all of these are model codes. They're not mandatory codes. But as you can see here through the 80s and kind of through the 90s, the model energy code and the successor ICC just kind of piddling along. But based on this explosion of building science knowledge in the 90s, in the early 2000s, the ICC pulled together a big group of stakeholders and said, okay, we can do better than this. And there was a sharp change in the stringency of the code. And this level that we're at, the 2015 insulation requirements, you see we're not even to the most recent code yet. So you can be sure that as successive versions of this certification program roll out, that these requirements are going to continue to accelerate. And you can see here, this is from the ICC themselves, that they foresee from the 2021 version of the code to have basically a direct line to zero. So they expect their code to be a producer of zero energy homes. So we have a lot to look forward to in this realm. So the third requirement is one of those that I'm mentioning that it's really design related. It doesn't fit into any of our other 3 categories. and it's for interior ducts and air handler. You can't put those in unconditioned spaces. It's a little intimidating at first. I would recommend that you look through those tour of zero and find some people that have already done the certification and talk to them about how they did it, or call me. I've spent a lot of my career working with interior ducts. I've written quite a bit about them, and I've pulled some of that material together for you, and it's from the Building America Solution Center, which if you haven't used that, I strongly recommend that you take a look at it, because it offers things like a summary of interior duct construction and several different methods of doing it, which I'm going to show you a few right now. The principal ways are to either build a chase below the ceiling level. We call this a fur down, where you come in and you create an air barrier at the same place that the rest of the ceiling is going to be. And you essentially create walls and a chase around that duct system, and it looks like this. This is one of our builders in the Gainesville area, and he uses these duct chases architecturally to create a separation of space. The other way, which is a little more challenging, is to create a space that rises above the ceiling level. That's called a fur up. In both these cases, the air barrier is really the big challenge. And you can see in this picture of this fur up that the worker is mudding and taping these joints just like if they were the finished ceiling, because they are, in essence, the finished air barrier. You'll note here that this interior air handler closet has a dedicated return plenum, and it's a central return, which is very common in Florida, but in many areas of the country, obviously, a fully ducted system is the norm. And unless you have something like a conditioned basement or an unvented attic where you can house one or the other, the supply or the return, I find it practically impossible to do this with just a fur up or a fur down, because there's just too many points of crossover. But there are other options. As I mentioned, ducts in an unvented attic qualify as being in conditioned space. And you could also go ductless with the mini split. We have worked with builders who, in addition to putting in the mini split, created airflow from the main body of the house into the bedrooms using a transfer fan and passive return air vents. Another option, which is considered one of the equivalent processes to create interior ducts, is that we bury the duct system essentially in insulation in the attic, but we also, before we bury it, we encapsulate it with spray foam insulation. I've never personally done this, but I know other Building America projects where it's been used, and if that's something you're interested in, we can certainly connect you with some of that material. The water heating requirements is kind of another area where there's not a specific code or standard that we can just point to and say, do that. Instead, this program gives us two paths. One is just design the system to minimize standby losses by limiting the length of the run between the water heater and the farthest point of use. The second path is that you can have a little bit more volume of water if you install a higher efficiency water heater, which is set by standards, and a package of WaterSense labeled faucets and shower heads, which is a certification program. So you can see that the combinations of these different mechanisms really rolls together to give a great deal of flexibility of kind of picking and choosing the level of stringency that this program draws together. And here's another example that this Energy Star labeled pretty much practically all of our major appliances. And those appliances became, those labeling programs grew out of the same sort of appliance standards concept, where originally this energy guide was developed to give people a sense of what was using a lot of energy and what wasn't. And that rolled into the opportunity for manufacturers to advance performance and pave the way for product standards in the Energy Star program. The other thing that this kind of work does is that it pulls things out of the R&D process into the marketplace by giving them a path of entry where people are interested in seeing what the next big thing is. So the 6th and 7th requirements are certification the 6th requirement is a certification program, and this is one that you really need to take your time with. If you're not familiar with EPA's Indoor Air Plus, you need to read the standard, you need to look at the checklist, you need to do a detailed thought process about how you're going to meet each one of these requirements. One that people struggle with, I think the most, is material selection. So this is one that you really need to get on top of before you make a decision to try to certify under this program. And the last one is it's a standard, but it is a standard that the Department of Energy pulled out of a larger standard for renewable energy readiness. So it's a very abbreviated version of that. And it only applies if the following 3 criteria are met. It's based on your zip code and how much solar radiation actually falls in your area. The shading of your site, if you live in the middle of a forest where your roof is never going to see the sun, then this requirement doesn't apply to you, as well as the house design. If you don't have enough free area within 45 degrees of due south, also this does not apply to you. And they have a table in their one-pager about this that shows the amount of area that they expect you to have to accommodate a future solar array. So they provide a link in this standard to go and see what your solar availability is, but it doesn't work. This is the link you should use. That one's broken. So you basically go to this website that NREL maintains, and you put in your zip code, which I put in my zip code right here, and it takes you to a default type, kind of a basic type system. You don't need to worry about modifying any of this, because all you really want to do is to go to the next step, where it is going to tell you on a monthly basis what your solar radiation resource is. And for my area, it exceeds the 5 kWh per meter square per day. And so based on that criteria, I would be required to do the PV ready aspect of the requirements. So just to summarize, how did we get here from where we started in the 70s with those huge solar arrays and the passive solar homes to this wonderful consolidation of basically everything we know how to do at this point? And this 5 decades in the making, all of the blood, sweat, and tears, and I mean that literally, and the hours of analysis and arguing and committee work and correcting other people, correcting data, analyzing the simulation models, all of these things rolled up into this program really give us the opportunity to do something that would have been unthinkable 50 years ago, absolutely unthinkable. So while the original jumping off point was in the 1970s, I want to challenge you that your jumping off point is today. To pick one of these requirements that you're not familiar with, research it, go through the process yourself, and come up with some questions and reach out to somebody that's already done the program, or reach out to me. There are program managers here at EEBA for this program, and we would love to see you be the next person that certifies under this Zero Energy Ready Home standard.